Hey, we're going to do graphing worksheets today, so this is going to go, again, pretty quickly. It's not a long one. What you need to do is you need to create a graph with this information. Now, there are a few things you need to do to be able to create a graph. You need to be able to figure out what your independent variable is and what your dependent variable is. The first one is always your independent variable. This is the thing that you are changing, and then the pressure over here, the second one is depending upon what the first one is. So you'll notice if the first one is 30, it forces the second one to be 425. If the first one is 40, it forces the next one to be 430. All right, stop that. All right, so I'm going to create a graph. Right, and my graph down here is going to be temperature, and it's going to be in degrees Celsius. And over here I'm going to have pressure, and it happens to be in PSI. Right. So now let's look at our temperature. Well, the temperatures we're given are 30 and 40 and 50, and we're not given 60 and 70, and then we're given 80. Right. So what we will notice if we look just at 30, 40, and 50, this is 425. Realize obviously this is not to scale. Right, but there's 425, which is here. There's 430, which is here, which is my next one. And then I've got 435. Now, if I were drawing this on graph paper, which would be great, because then I'd have a real accurate representation, you'll notice this certainly looks like a straight line. Right? Now, you'll notice that my next pressure up here is 450, so I skipped a bit. So I skipped 440 and 445, and I went up to 450, and at 450 I hit 80 degrees Celsius. Now you should at this point realize that what you have here is you've got a straight line, and you should notice that every time my temperature goes up by 10 degrees Celsius, my pressure goes up by 5 pounds per square inch. Right, so I do have a ratio of 10 to 5 or 2 to 1. Right? So I do have a straight line and it remains consistent. So what you should be able to do is you should be able to interpolate data which says at 60 I'm going to have 440 and at 70 I'm going to have 445. And that's important because that's what our questions are. So as you're drawing your graph, you should be able to figure out what your independent variable is, your dependent variable, and then be able to draw your graph. In this case it's linear. And the question said, what's the pressure at 60 and what's the pressure at 70? Well, I already answered that. Right? At 60, it's going to be 440, and at 70, it's going to be 445. The question is, what is it at 100? Well, I don't need to draw a graph to do that. You can draw a graph, right? And then you could go and extend your line all the way to 100 if you have this nice graph paper that you've done this on. But I also happen to notice that I'm going up by 10s. Every time I go up by 10 here, this number is going up by 5. All right. So if I'm trying to go from 80 and I'm trying to go up to 100, I have to add 20 down here. I have to go up by 10 and then plus 10 again. So that means I'm going to go up 5 and I'm going to go up 5 again, which means at 100 I'm going to be at 460 pounds per square inch. So you should be able to predict what's going on there. Okay. Now let's look at this graph. This graph looks very complicated, but realize I'm only concerned with one line, which is this line right here, which is my KNO3 line. Okay, and it says at 70 degrees Celsius, well here's 70 degrees Celsius, so that means I have to go up this line right here. At 70 degrees Celsius, how much KNO3, because this is KNO3, can be dissolved in 100 grams of water? Well, you'll notice that I'm dissolving in 100 grams of water over here. Right, so I look at 70 degrees Celsius and I come up to see where these two lines intersect, and those two lines intersect right there. All right, so I notice that at 70 degrees Celsius, I can dissolve 130 grams of KNO3 in 100 milliliters of water, or 100 grams of water. So what happens if I go up to 300 grams of water? Well, I've tripled the amount of water. Haven't changed the temperature. Temperatures remain the same. Well, if I can put 130 grams of KNO3 in 100 grams of water, and now I have 3 times as much water, you would think that this number here would go up by a factor of 3. and in fact it does. You multiply the number by 3, and you get 390 grams. And that's our answer. And that's it for this worksheet, I think.